In this video, I will show you how to do the remaining parts of plumber block assembly using SolidWorks software. Disclaimer: this PPT has been prepared by referring many sources which include figures, diagrams from internet as well as from the prescribed textbooks and reference books. I do not claim any originality in preparing this video or PPT. This PPT or video is exclusively for purpose of education, not for any financial gains. I wholeheartedly thank all those who have directly or indirectly contributed to do this PPT and video. The next part of plumber block assembly is bearing bottom off and bearing top off. These two are similar, only the difference is see third one and fourth one. Bearing bottom off is this one and top off is this one. The only the difference is at top bottom of have a projected pin and top of have a instead of a projected pin it has a hole. So we'll do one, then we can make a save as and we'll do small changes in the next one. So for this one I need to go to revolve command. So for that one you can draw this sketch in a front view so that it can revolve. So go to front view, go to sketch, select the sketch, then front view, make it normal. Okay, now we can draw this profile. Draw an axis line first. The midpoint of axis line should be coincide with the datum point, then this line should be horizontal. So for that reason only I draw initially inclined shape. Next you can take an, if you know the distance you can draw a distance. You can give a dimension to this one as 50. This will be the distance is 50. Next you can take a line and you can project like this. See, from here one pin, project upward, downward, again little bit, then draw a line. Reach on it. See, now the work is dimensioning. Before that one I can draw a, you can make these two are equal. You can make equal or you can make symmetry. I feel the symmetry will be the better. So you can take a midpoint of this one and click on this vertical axis line, make it vertical, and you can select the one line, second line, third line and fourth line along with the axis line, and you need to select here also first, second, but you need to hold a control button while selecting. Then after selection of this one you will get an option as symmetric. You are not getting it. If an axis line so symmetric relationship is not coming. So we'll make these two as equal. This line is equal to this one. Right, and even this line and this line is equal to, and these two lines are equal, and these two lines are equal. Now you can draw the dimension. See the Initial diameter what we have is only this profile we require. We need to draw one more line over here. So that should be the diameter is outside we know 50 and these two are 36. Then these two are between this is 22. And the distance, and if you want to the diameter you can see here the first one is 25. So first I will draw the outside one. Larger diameter will be the 50 from here to axis line. You can select, see this should be 50. Okay, next next one is 38. 38. The next one is 35. You need to cross the axis line. Otherwise it will give the distance. If you cross the axis line, then it will show the diameter. See, it is around 35 is done, right? Next is 35. This one is 35. This should be 38. No, see the 35. Then the last diameter is 25. That is normally you can say whole diameter. These two lines you need to trim. Go to trim. Go trim these two lines. And again it will ask the distance between these two. Overall line width position is 50. Then exit sketch. Exit sketch. You need to make a revolve. Go to option as revolve was. Select the profile. It automatically take the center line. So the center line axis line should be this one. Now we don't want the complete rotation. Now for that one you need to give an angle here as 90. See, half of that side we got, and you go to direction 2 and that side you give 90. See, both the side we have 90, 90. So I'll get the bottom. Only thing is we need to have a pin, the projected pin at the exactly at the center. So for that one you can go to select this face, make it normal. So again above this face is not possible, no? So for that what you can do, one ways option is we can say go to select the same top view, make it normal, and you can draw a circle of diameter of exactly at the center of 6 diameter. 6. Now while extruding this one, we should follow some steps. So for that we can't make this one, right? That should be above the surface of this one. So for that one you can take here from surface. So you can select this surface. So from that surface it's going this direction. We need to change the direction. Change here the direction. Now see, from the surface it's projecting out. Now what is the distance? That should be 5. That can be given over here. 5. You okay. See, I draw the sketch on the uh, top plane. Then while extrude that one, I select the surface as this one from the offset from that surface. Then I give the dimension so that you can get. See this off surface curve, everything you should match. Yeah. Now give a color to this one. Go to right click on this one. Then appearance. In the appearance, go to part 2. There you give the dimension. Sorry, color. Once you give the color over there. Okay, save and go to file and save it with respect to your name. The name is as the shows in here. So bearing bottom. Now I will again save as this one because I want to make up a top of, right? So I'll make save as of this one, bearing top of. Save. Now you can see the file name as bearing top of, right? Then you can edit, or you can see here also file name. This will be the file name, and the part name will be always same, right? If it is a single part. So there we need to now, what is the bearing top of difference is, we need to delete this one, boss extrude, delete. So the sketch will be there as it is. So you'll use the same sketch, edit sketch. What is the sketch diameter? It should be, again it is also at the center, it should be 4. So change to 4 mm. Next I can give the cut extrude because it has to go through all, right? So exit sketch, cut extrude. So I can select the sketch. So I can give as through all instead of blind. So it can be through all also, no issues. It won't touch anything. Where we required, we will get the hole. So this will be clear. If you want, you can keep it in isometric view and you can save this one. After changing updates, you can go over to file and you can save it. So the bottom off and top off is also done. The next parts are bolt M10, nut M10, lock nut M10 and shaft. Some of the parts you can create yourself, or you can, what do you call, you can take it from the library of SolidWorks. So presently for the SolidWorks we will do modeling of this one also. So go to file, new part. So now in this one, for first I will go to the next part after the bolt M10, the part number 4, no, not the 5 bolt M10. This will be the that part. So for that one I'll go to first extrude, I'll go to top view, I'll put a square, sorry, rectangle or square. You know the dimension is given as 18 dimension, both side. Then thickness as they given as 6.5. Project extrude that one to 6.5. 6.5. Then you put. Then on top of that one, you can need to go to again extrude. Select the top face plane and make it normal. Draw a circle of both sides. When you say M10, the diameter should be M10. Extrude, exit sketch. Then rotate this one using a scroll button by pressing the scroll button. Then the length is given as 75. Then type the distance, it is as 75. Okay. And here we require a chamfer. Chamfer details not given as they given in the note, right? If the dimension was not stated, then you need to assume chamfer as 1:45 and radius 1. So in this case we require a chamfer, so we'll do the chamfer over here in this corner. So go to fillet, not the fillet, in near the fillet below arrow mark button, choose chamfer, then in parameter, in chamfer parameter type 1 mm, 45 degree will save as it is, and select this edge. You will get a chamfer like this. Now I need to cut this one, right? This round we need to make. So for that one you need to cut an arc. For that one go to, now I need a plane like this, or I want to take a plane, that one. For that you can say it is, so how much the angle we need to cut, how you are going to decide it? So for that one they have a standard one. I think you have studied in the CAMD theory. So I'll show you that one also. Hexagonal nut. After that we have square nuts. So in the square nut we need to cut an arc like this circle. So that should be the radius over here. Can give, see chamfer line. They given us 30-degree chamfer line you can cut. The 30-degree chamfer line, right, at an distance is, let's see, chamfer of 30 degree. The distance is, circle diameter is 1.5D into 3 mm. From there we can make a chamfer. Move to SolidWorks. So let's go to the planes. So we have a plane of this one. Make it sketch, or sketch. Select the plane. Make it normal. Here to cut this one, you need to take an axis line from here as the given. That should be, the diameter should be 1.5. So the distance of this line should be 1.5. 1.5 is the diameter, is the square. The diameter is M10. That should be the reference D. D we know it is a 10. So 1.5, that one means 15. 15 plus 3. So it should be 8. This overall length. We are doing half of the 10, so it should be 9.5. From there, draw a chamfer line. This chamfer angle it can give as angle to this surface. This should be, instead of 30 degree. Because we don't know the length of this one, so what we'll do, for the safety purpose, it will be a little bit more. Then exit sketch. So for that one we need to make a revolve cut. So for that we record a edit sketch, axis line. So draw an axis line over here. So it should be revolve cut. Exit sketch, features, go to revolve cut, select the sketch. So it took the axis line there itself. Go to the axis line rotation, delete this one, right click and delete, then select the axis is this one. So you can see it can going to cut the material. You okay. So it will cut the material of how much it is required as the angle of 30 degree. So keep it in isometric view. I want to give a color. So save this one as this is the file name we required. Bolt M10. Bolt M. Save all same name which is available in the bill of material. So again, right click on the Bolt M10, go to appearance, change the color so that you can able to identify the different components in a different color. Right? You okay. Then again save because we change the color. Close it, we don't want this part. Even we don't want this part. So go to file, new part. Now here for this now we need to make a two nuts now. Lock nut M10 and nut M10. So for that one you need to make an hexagonal. Go to top view, sketch. On the top view type and you will get the icon like this. Select that one, it is a sketching mode. Now here we go to polygon. Select the polygon. Anyway the sides, if you want to vary you can type here the sides how much you want. If you want 6 you can keep as it is. Now we need to give a circle diameter, right? So how much is the circle diameter? So again that is also standard, you should know that one. That standard is over here, right, in the hexagonal nut and bolt. See in the hexagonal nut, so you can see the diameter over here. The inner circle diameter we want, so here we'll get, see the inner circle diameter is 1.5D plus 3 mm. The same value you can give here also. So go to SolidWorks, dimension, right click on the dotted line circle, there you can type the value as 1.5 into D is 10 mm, then plus 3 mm. The same way you can type. You got 80. Now it can able to rotate, for that one you need to constrain by taking the reference like this, by referencing moving from the data point. Now after this, so can we close as it is? No, I can do circle also, hole also, right? So I can draw a circle at the center. What is the diameter? It should be, now you can draw circle and cut, or you can make a hole wizard option, you can make a hole. I can better, you can do a hole wizard option so that the threaded line indication also can able to see. The what do you call, the 3/4 circle you can see, right? That is the threading symbol in the drawing. So I need to draw that one also. If you do like this now itself, you could not able to make that one, right? For that one what we'll do, circle we don't want, we'll make a hole wizard option. So I deleted that one, exit sketch, and the thickness they given here, go to extrude, give 10 mm. So not the 10 mm, it should be 8 mm because they given in the sketch. Otherwise we have a standard as it should be around what do you call, 1.5D or D, 0.9D or 0.8D thickness, right? The standard. Now I will cut a revolve cut, the what do you call, the chamfer we'll do first. Go to front plane, sketch, make it normal. Here also you can draw a line area and the distance. As we know, for that one you require an axis line. You can draw an axis line. Then the distance of starting point should be the one, should be diameter. You know the symbol, right? If you cross the axis line, then it will show the diameter. Otherwise, it will give the distance. So I will delete this one because I want to know, I want to draw the diameter. So click it over here. Now the diameter is 1.5 into D. D is 10 mm plus 3 mm. So this will be the diameter 18. Then the angle, the chamfer angle should be from here to here, it should be 30 degree. Chamfer is 30 degree. Then end sketch. Then make it revolve cut. Not the revolve, it should be revolve cut. So it took automatically this axis. Here I draw only one axis, so it took automatically. View OK. Then same thing should be copied to other end also. For that one I need to make a mirror. So for that I need a plane. So now to mirror this in exactly, so I need a plane. So what will do for the safety purpose, I will extrude the boss. I will what do you call edit the boss feature. There the thickness are given in a single direction, right? There I will, instead of blind, I will select the mid plane. I will select the mid plane, so that what will happen, I have the top plane at the mid. Now this plane I can use for to mirror. Select that plane, top plane, go to mirror, then feature, you need to select the feature over here, cut revolve, or you can select the face of that one also. See, it was mirrored. Then I need a hole, so make this face as a normal, then go to hole wizard. So we need to make a thread, so select the here straight tap option, then ISO. Instead of bottom tapped hole, it should be tapped hole, right? Then you need to select the size at hole specification. It should be M10. If the pitch not specified, please select M10 directly, right? If the pitch specified, you need to select that particular pitch, 1.5 or 1.25. Otherwise, you use direct one, right? Then what do you call, the distance is not required here, even though if it is a through hole, because that's why I'm not worried about the distance, because I have a workpiece thickness as only 8 mm. Here the distance is 27 mm. So anyway it will go through that one, all full throughout the material it will cut, so no need to change that one. Go to position. Now select the face first, then select the data point, then give OK. Now you can see hole, and this circle, additional concentric circle, will indicate the thread. Yeah, and you can measure the hole diameter will be, here it will show the hole diameter will be 8.5, because if it is a 10 M10 hole, you can't make a M10 hole, because the threaded dimension should be 10 after threading. Threading the for the internal hole, outer, so larger diameter of the thread should be 10. So not the minor diameter. So that's why the minor diameter will come at around 8.5. Now go to file. If you want, go to change the color, right click, appearance. So bold color be given as this one. So I'll give light color. That have a difference. Now I need one more nut, lock nut as M10. So I first save this one as nut M10. Next I will file save as this one as lock nut M10, and I will edit the same part, lock nut M10. Then what is the difference here? The size, the depth, and everything is same. Only the thickness of the workpiece should be less. So for that one, we need to edit the first feature. Boss extrude, right click, first option edit feature. Then instead of 8 mm, you can give 5 mm. Then color and everything will be same. If you want the difference, so you can change the color. Right click, edit feature. Right click, edit feature. Click it over here, and you can change the color. We'll make it a little bit dark. Understood, right? Then again, make it save, because after what you call save as, you did some changes. Then update it. Then close. The next part is shaft. So file, new part. The shaft diameter they given as 25 and the length not specified. This indicates the length is not shown. The entire length you could not able to show. Length you need to calculate. How you going to calculate it? So you need to check the housing assembly. Inside this house, the bearing, these two will sit, right? What do you call the bearing? Bottom of and bearing top of will sit. So you need to check the length of that one. It is length of that bearing top of and bottom of is 50 mm. So the shaft length should be more than that one. So go to front view, extrude, draw a circle of 25 mm, as they mentioned diameter as 25. 25. If you want, you can cross check, see 25. The D8 is fit, the fit and tolerance. The diameter, shaft diameter should be having the fit of D8. That is nothing but the tolerance of that particular shaft. Now, those things while drawing we need to give, not in the modeling. So the length should be more than 50. So what I do, I will make it 70. So both the side 10 mm will be projected outside. I will make this one also in the mid plane. Extrude in the mid plane. Now given color, right click, edit, appearance, click on the part and view as any one color. So I'll make it as yellow. Then file, save as shaft. So whatever the file name should be, you need to maintain the same file names, so that after assembly you will do the drawing, then you need to import this bill of material. That's why you need to maintain the same names. Thank you. For further details, you can contact me, Sandeep S, Department of Mechanical Engineering, Canada Engineering College, Pantola, and my mail ID is sandeepmysore07@gmail.com, and my contact number is 9900 Any clarification or any information, you can contact me with respect to this video. Thank you once again.